Good morning everyone. Today I am going to discuss about the shift registers. Why you prefer the shift registers? Shift registers are transfer the value from one iteration to the another iteration. That's why you are using the shift registers. Mostly shift registers are preferred in for loops and while loop. For loops also values one by one added and incrementing also one iteration to another iteration. And coming to the while loop also you are using the one by one, counting the one iteration to the another iteration. That's why shift registers are mostly preferred in for loops and while loops. And coming to the what is the shift registers? Shift registers is transfer the value from one loop iteration to the next loop. Here shift registers occurred in any loop, for loop or while loop. There occur two shift registers. One shift register is opposite to the next shift registers. That is appears on the for loops or while loops. And coming to this is a schematic diagram of the first one showing the while loop. See, I is showing how many iterations. Iterations is starting always from 0 and up to what you want value. And this is a shift register. See how it occurred in shift register from right side and left side. One side is opposite to the another side shift register, both registers. And coming to the for loops also, n is showing how much iterations you want. You keep this here, n equal 5 or 2, 3, 1. This one shift registers is opposite to the next shift registers. The I equal to always starting from iteration 0 to up to what value you are given here. That value will appear to this one. And coming to the iterations, how it occurs the iterations. See, this is a before loop begins. You here you keep this value in initial value is the shift registers. This is a while loop. And coming to the first iteration. First iteration means you put on the initial value. Before you added the one by one shift registers, first shift register is the initial value and second shift register is what you want your value before adding the previous value, and now you are adding the shift register added. Both values are added. It is coming to how many iterations you want added the one by one shift registers. This is the most useful for using in a while loop and for loop also. Coming to the how it assists the shift registers in while loop or for loop. For loop. Okay. First of all, take the one block diagram. Coming to this one, this is you simply put on the right click or left click on either left side or right side. You simply put on the one click. They are showing the add the shift registers. You simply click that one, add the shift register from right side and left side. Both are opposite. This is a while loop. This is a for loop. And coming to this is an example for the shift register. Here I take the for loop. Here n equal to 4. 4 means 4 iterations. First starting iteration is 0 to 3. Because here using the 4 means 0 to 0 1. Always starting from 0 to up to 3. Okay. Here using the two values. One you want sum and another values you want product. Here coming to this one. Here using the you want to divide the first how much you want sum and another one is also here put the 5. How much first starting always here using the increment operator. Why you prefer the increment the value from how much you want value. That's why you prefer the increment operator. It is adding. Plus is adding the operator. Okay, first of all, how many n equal 5 means starting always 0 to 4. Okay, first is starting is always 0. 0 is increment by the 1 and 1 is increment 1. Here using the plus 1 plus is how much initial value 0. Here display the output is 1 value. And again coming to the iteration is 1. 1 is increment by the 2 and 2 plus 0, initial value 0. How much before already display 1, again now plus 2, 1 plus 2 equal to 3. And again coming to the 2 and again increment by the 3. Again here initial value 0 plus 3 up to added up to 5. How much is the sum equal to 50? You got 1, 3, 5, 7. Total you got the output is 15. Again same thing here also, it is the product. We are getting the output is 30. Coming to the factorial program, it is another example for the shift register. Here using only one shift register. Okay, here also number of counts equal to 5. Number of counts. Again iteration always start from 0 and their starting equal 0 is increment by the 0 is increment 1 and 1 is multiplying the how much is initial value you keep in shift registers. 1 into 1, how much display 1. Here display the output is 1. Again 1 is increment by the 2 into 2 and 1 and before 1 is there. Now 2, 1 into 2 equal to, here multiply means multiplying the 1 into 2 equal to 2. Again here 2 is increment by the 3, again 3 is multiply 1 and again here 2 is there, 2 is multiplying the 3 equal to 6. Again 4, 3 is incremented by the 4 and 4 is multiplied already. How much 3 is there? 12. And again how much here? 4 is in initial value 4 and 4 is increment by the 5. Here multiplying operator, the 5 is multiplying 1 into 5, 4 already is there, and to 5 how much total you get the 120. Factor 5 factor equal to 120. Here using 1 is increment operator or multiply order operator. Use the for loop and for loop use for the number of iterations you want. Shift registers also count the 1 by 1 value. Here putting the initial value means initial value multiplying the how much value we are increment, that both are multiplying and display the factorial value. That is a 5 factorial means 120. Is a coming to the while loop. While loop also here using the don't give the number of iterations. Here using the equality operator is connection to the true. The symbol is shows the true or false. True means continuously true is executing. False means false. You are getting the false means total false. True false means you getting the true means only true is operator and false is stop. False means false you getting and true is stop. Here using the 5. How much? 5. Here also same thing. Equality operator and increment operator and multiply operator also. First iteration is the starting always 0. 0 is increment by the 1 and 1 is multiplied. How much initial value is there? 1. 1 into 1 is here display the factorial equal to 1. That is equal to the 5, not equal to 1. And again 1 is increment by the 1, 2 and again 2 is multiplying the initial value how much 1 and it display the 2 already before display 1 into 2 equal to 2 and again 2 is increment by 3 and 3 is multiplying the 1 and 3, 2 3 is a 6 Again 4, 3 is incremented by the 4, 4 is multiplying 1 into 4, 6 4s are 24, and again 5, and 4 is incremented by the 5, and going back to the multiplying operator initial value, how much initial value 1, and both are multiplying is the 5, and it is the 24 5s are equal to 120. This is the same thing is repeated. How much you are getting 5 factorial means also 120. There also for loop also 120. Mostly shift register. Why you prefer the shift register means transfer the value from one loop iteration to the next loop, counting the value from one value to the another value, adding the one shift register to the another shift register before how much you got, that value is added to the next shift registers. That is a very simple pull to count the values from one loop iteration to the another loop iterations. That's why you prefer the shift registers. Okay, this is a brief discussion about the shift registers. Thank you, sir.